Two bags A and B are on the table. Bag A contains 5 red balls and 3 white balls, while bag B contains 2 red balls and 6 white balls. A bag is chosen at random and 2 balls are drawn from it, one after the other without replacement. Find the probability that the 2 balls chosen are of different colors. So we are going to prepare a tree diagram for this. We are told that a bag is chosen. There are 2 bags, and therefore we have 2 options here. So it's either bag A or bag B. And because there are only 2 options, the probability of picking from bag A is a half, and also that of picking from bag B is a half. Now we have 2 balls picked from the bags. This should represent the first picking. So it's either a red ball or a white one, red or a white. So this is for the first picking. Then we'll also add for the second picking. So the option is it's either a red or a white. So this should give us the second picking, all of this. So if you are to pick from bag A, we are told that bag A contains 5 red balls and 3 white ones. So for the first picking, we have 5 reds. So it is 5 out of a total of 8. So we have 5 reds and 3 white ones. So the total is 8. So we have 5 over 8. And for the white balls, we have 3. So it's 3 over 8. Continuing to the second picking, if we had picked a red ball in the first picking, then that means that for the second picking, because the picking was done without replacement, the number of red balls will reduce in the second picking. So here they should be 4, and also the total number of balls is now 7. So we have 4 over 7. And when we picked a red, that means whites remain the same. So we have 3 over 7. Another thing we need to take note of here is that if we take the probability in this branch and add it to this other branch, the sum should be 1. So here we have 7 over 7, and here was 8 over 8. Now if from bag A in the first picking we had picked a white one, then the number of whites in the second picking should be 2. So it's 2 out of a total of 7. And then because we picked a white, a red was not touched, so reds are still 5. So we have 5 over 7. For bag B, we are told bag B contains 2 red balls and 6 white balls. So in the first picking, we have 2 red balls, that is 2 over, so 2 red balls and 6 white ones. So the total is still 8. And for the white ones, we have the probability as 6 over 8. Now in the second picking, if we had picked a red in the first picking, the number here reduces by 1, so that we have 1 over 7. Remember, it is picking without replacement. And then here, the number of whites remain the same because we had picked a red one, so whites are still 6 over 7. And suppose in the first picking we had picked a white, that means the number of whites will reduce by 1, so that we have 5 over 7. So that is for the second picking. And because we had picked a white and not a red, so the reds remain the same, so they are still 2. So that is 2 over 7. Now from this tree diagram, we can have the sample space, that is a list of possible outcomes. For this first part, we have picking from bag A, and both of them are red. Picking from bag A, the first one is a red, followed by a white, so just following this path. Here we have A, white, red. You have A, white, white. B, red, red. Here B, red, white. Then B, white, red. And finally B, white, white. So the question required us to find the probability that the two balls chosen are of different colors. So where we have different colors are here, here, because you have red and white, white and red, red and white, white and red. So those four areas. Now we are going to get the probability for this added to this, this and that. So for the first part, let's begin with this one here. We have, if we follow this path, we have a half times 5/8 times 3/7. That is for the first one, and then we'll add that to the second one. Following the path for this, it's a half times 3/8 times 5/7. The next one we have for this a half times 2/8 times 6/7. And lastly, a half times 6/8 times 2/7. So this first bracket here should give us 15/112, and is the same result we get for this second bracket. And then for this bracket here we get 3/28 plus this other bracket also 3/28. When we add all these, our final answer becomes 27/56. So this is the probability that the two balls chosen are of different colors, just as had been desired in the question. Now with this, we mark the end of the solution to this problem. Thank you for watching. See you next time.